now. There's still a few people to join, I think. There's 41 in the class in total, so there'll be hopefully along fairly quickly. Anyway, today we have Grant Waldie from Parsons, who's going to talk to us about his experiences with bridge inspections, etc. And I will let him do his introduction. And Grant, anytime you want to start, he's going to share a screen and hopefully famous last words.
Famous last words, yeah. Well, I believe you let me know as soon as you can see my screen. I think you can see it now. Is that correct?
Yeah.
Perfect.
Everybody good? Anybody having problems that is connected here? Just let us know. I can see it. That's good. Jennifer can see it.
Perfect. So what I've done here is I got two screens on my end here. So on my right screen, I'm seeing what you're seeing, and then on my left screen, I'm going to have the chat open. So if at any point you want to jump in with a question, ask it. I might not answer it instantly because I might just kind of finish the slide. This is totally a back and forth kind of interactive presentation. So whenever you have a chat, whenever you have a question, I have the chat open right here and I can see. So hopefully I can answer your questions. So yes, welcome to my presentation today. I gave this same presentation I think 2 years ago. For Peter's class. I've updated it with a couple new photos. So just a quick overview of what I'm going to talk about. I'm going to tell you who I am. I'm going to let you know what my current job is. Then we're going to talk about how you plan a bridge inspection. So you can kind of guess that my current job is that I'm a bridge inspector, but I will get more into that. Then we'll get into some of the actual particulars of how you carry out bridge inspections, different standards that are followed in British Columbia, how they differ across Canada, and then how they differ in the United States. I'm going to talk about how we write the report. I'm going to talk about kind of the differences between simple reports versus complex reports, complex databases. We even do things called structural health monitoring, which if some of you go to UBC, and then if some of you go on to get a master's or a PhD, you might be telling me how to do that, because structural health monitoring is kind of on the very forefront. It's the PhD level of bridge inspections. I more so specialize in the simple report. I can certainly talk about these other ones. And then I'll talk kind of from a business point of view of how you take the inspections and then how you grow your business and how that can move into different types of projects. It's a really great way for our company to bring in a ton of work. We start with bridge inspections, which might be in the order of $5,000 to $10,000, and then we have all this add-on work that comes. And it can sometimes end up being multi-millions of dollars. So I can talk about that from kind of a business perspective. All right, so my background. Well, I'm from Victoria. I went to Reynolds High School, and I graduated in 2005 from Reynolds, and so I'm 33 years old now. I went to Camosun College, and I did the bridging program. And I did it back when it was a quarter system. So we did 3 months of courses, then 3 more months, then 3 more months, and then we had 3 months off. And I did the bridge program, which back when I did it was 6 months long. I graduated from Camosun College in 2008. And then I went on to UBC, and I got my Bachelor's of Applied Science. And throughout that time, throughout Camosun and UBC, I was working various different summer jobs. I worked in construction. I had some engineering co-op jobs. I would highly encourage everyone that's listening to get a summer job working in construction. It really makes you far more employable. Every boss of mine that I've ever had, or every interview that I've either been on the side of the table where I am interviewing, or I've even sat on the other side of the table where I'm interviewing people, if they have some construction experience, it really puts you ahead of everyone else. So that's kind of my first little tip here. As an engineer, a lot of times it's our job to tell people how to swing a hammer. If you've never swung a hammer, you don't know what you're talking about. So I really want to encourage everyone to get at least one summer job working in construction or some sort of manual labor job. After I graduated, I went to go work for a company called Delcan, and I've been there ever since. So I started work in the Vancouver office. I had moved to Vancouver to go to UBC, and I started working in their Burnaby office. And after I'd worked there for about 5 years, they got bought out by Parsons. So same company, same people, just different letterhead and different email address. So that was where I worked for my first 9 years. And then in 2019, I started to explore the idea of maybe transferring down to the US offices. And it is a long process of moving legally from Canada to the United States. I started it in January, and it was in October of 2019 that I actually transferred down to where I am right now. So now I'm in Denver, Colorado, and I love it here. Everything's going really well. Still the same company, but I'm now working with different people. I have my PEng and I have my PE. So I'm trying to remember. I have my PEng in BC, Alberta, Saskatchewan, Manitoba, Ontario, and Nova Scotia, and I have my PE in Illinois, Washington, and Texas. And the reason why I have so many PEngs and PEs is because my job, I kind of need to have them. I should have even more because I work in even more states and provinces than that. It's my job to be a bridge inspector. So to put that in just really, really simple terms, Monday morning, I go to the airport, I get on a plane, I fly somewhere, and then Tuesday, Wednesday, Thursday, I'm putting on rock climbing gear, and I'm climbing around a bridge, and I'm taking photos and measurements. And then Friday, I'm flying home. And then the general rule of thumb is that for every 1 week that you spend doing inspections, you spend about 2 weeks writing reports. So I might be, away for a week, and then I'll be back for 2 weeks, organizing the photos and writing the various different reports. That's in a good year. That's in a non-COVID year. I remember 2 years in a row when I spent 26 weeks on the road. That was way too many weeks to spend on the road. So part of me moving down here, I was talking with the various different managers and saying, I'd rather spend about 6 to 10 weeks on the road, sort of thing. And when I moved down here, COVID hit, and I've only spent 3 weeks on the road during 2020. So COVID's been a very interesting year for a traveling bridge inspector, but of course it's better for my own personal life, not being on the road so much. Bridge inspection, that's kind of my primary area of focus of what I do. But I also help with layout design of various different roads and hiking trails. I also help with writing proposals and doing project management. So I'm kind of a jack of all trades. But when people ask me at a dinner party what you do for a job, I tell them I'm a bridge inspector. So here's a quintessential picture of us at work. This is a bridge. It's a bridge in Chilliwack. This bridge doesn't exist anymore, actually, because we did this inspection and we were climbing around the bridge and we found basically so many structural defects and so many different reasons why this bridge needed to be replaced that a brand new bridge was built right beside it. So that's kind of part of that add-on work. You start with the inspection. An inspection like this, it might cost $5,000, it might cost $20,000, kind of depends on the number of people on site, the number of days. That's nothing in comparison to a brand new bridge. Brand new bridges will be 10 million, 30 million, 100 million, even $1 billion for some really large bridges. So municipal governments and provincial governments, they oftentimes start with the bridge inspection because for a few $1,000s, they can get a good feel of what the bridge is looking like and what we need to do. There's two main things that we rate bridges on. We rate it on either structural deficiency or being functionally deficient. So a structural deficiency is something like, a beam is broken and therefore not as heavy a load can be on the bridge, or maybe even have to shut the bridge down because something is broken. That's a structural deficiency. And then a functional deficiency, this bridge had both. This bridge was functionally deficient. It only had 2 lanes. And when someone's trying to drive across a really narrow bridge, there's 1 lane northbound, 1 lane southbound. traffic has to pull over if somebody's driving a big wide trailer, and it makes this big, huge kind of traffic jam. So this bridge had both structural deficiencies and it was functionally deficient. And we did a whole life cycle cost analysis about what it would cost to widen the bridge, what it would cost to retrofit the bridge, and eventually the city of Chilliwack went with the idea of, well, let's build a brand new. A lot of people ask me, how do you get that job? How do you become a bridge inspector? Well, obviously the first step is you have to go through either Camosun or UBC and get your engineering credentials. When you start working in an engineering office, you're doing a lot of things, and sometimes you're doing admin work, sometimes you're doing drafting, a little bit of design. They tend to get you involved in a lot of things. But eventually, one of your bosses, if you work for a bridge, a company that does bridge inspections, will say something along the lines of, "Do you want to go to site?" And going to site and walking along a sidewalk and seeing things from the ground is one way of starting to learn bridge inspections. But eventually, you got to put on that harness and you got to go climb. So what we do in the Burnaby office, this picture here is, I think this is taken in Richmond, and what we do is we get a group of prospective bridge inspectors. This guy right here, we just hired. This guy's got about 10 years of experience, so it doesn't really matter how many years of experience you have with the company. Everyone in this photo has 0 years of experience of bridge inspection. Just because you think you're going to be a bridge inspector doesn't mean you're going to be able to actually be comfortable at heights. And we would much rather find out in this controlled environment how you deal with heights than paying all the money to get you on a plane and fly you halfway across the country and put you up in a hotel and then find out that you're afraid of heights. So this is kind of the first step to do here. It's climb the ladder. That's the very first thing. And I know a lot of people are kind of snickering and going, who can't climb a ladder? Some people can't, and I would much rather drive half an hour from Burnaby to Richmond, figure out you can't climb a ladder, and spend thousands of dollars and flying you across the country. So the first step is you just climb a ladder, see how comfortable you are getting on and off here, standing up here. Everyone's wearing a harness, so then we'll do things like we'll click you in, and everyone feels very comfortable when they're standing on this side of the railing. Then we'll say, climb over the railing and just stand on this other side. You're harnessed in, totally safe, and from a physical point of view, you're no less safe standing on this side of the railing than the other side of the railing if you're just holding on to it. Psychologically, a lot of people they freak out at that and they can't do that. And then to kind of basically, I want to say graduate the course, you have to climb up this ladder here, and then you have to climb onto these braces, and then you have to walk along this balance beam. If you can do that, this is about 2 stories in the air. And we say, okay, you're not afraid of heights, or at least you have a comfortable appreciation for the danger that heights can bring. Then I'll get you actually going to a bridge site. Most bridge inspections, we're not doing that sort of stuff. We're not climbing and doing balance beam sorts of things. A lot of the times we're just standing on a sidewalk. It is not too daredevil-y at most times. I'll show you this next picture. See the inspectors? Hopefully this isn't grainy enough here. Maybe someone in the chat can tell me if they can clearly see the inspectors. But this is a bridge. This is a suspension bridge. It's called the perfect. Thank you, Jennifer. So this is called the Thousand Islands Bridge. It's in Ontario. It goes between Ontario and New York. And there's inspectors walking along the cables. This is hundreds of feet above the water. You will absolutely die if you fall from that height. You're not getting injured, you're getting dead. You can't be freaking out when you're walking along these cables. Now they're all clipped in, and everyone has a harness on, and you have at least 2 clips. There's really no way possible for you to fall. But from just from a psychological point of view, you can't be freaking out when you're walking along those cables, because you're not just walking the cables for fun. You're also looking at all the different bolts, and you're looking at all the various different places where that cable is starting to come apart. You have to be in the right mental headspace that this is just like walking along a sidewalk for you. So if your heart is pounding doing this, you need to stick to bridge design, not bridge inspection, which is fine. We definitely need people who are field people and people who are office people. This is definitely a field person job. So here's a picture. This is at the Patella Bridge in Vancouver. And back when I lived in Vancouver, every time there was a minor earthquake, it was my job to go to the Patella Bridge to do an inspection. That bridge it definitely has some structural issues. It's definitely functionally obsolete for anyone who's been to Vancouver. And this is the bridge that goes between New Westminster and Surrey. If you've ever driven across this bridge, you know it's far too narrow, so it's definitely functionally obsolete. And it's also structurally deficient. In a major earthquake, this bridge will collapse. This is a bridge that the province has identified as one we're trying to replace. We've been working on replacement plans for this bridge for a long time, and it does come down to money. There's a lot of money involved in replacing bridges. So every time there's a minor earthquake, you can see me there. I climb up this ladder and I'm checking various different bearings and seeing if any of the members have had any problems. This next bridge it's the first bridge, the Thousand Islands Bridge, but this is up inside the bridge. So we sometimes call this the gantry-way or the walkway. When you're designing bridges, this is something to think about. You want to think about how is this going to be inspected in the future by future inspectors. And if you can build in a walkway like this, that makes things a lot easier, because a lot of times these old bridges, they don't have these walkways built in, and you go to inspect it and it's thousands and thousands of dollars to rig up all of the different scaffolding. If the designer would have thought of having scaffolding built in, permanently attached to the bridge, it's a little bit more money. It's a slight bit more money during construction, but it saves a ton of money in the long run. And this is really well done. So you've got the walkway you walk on. These are the handrails that you can clip into. There's an intermediate level handrail just from a psychological point of view, so you can't slip out this way. And there's even security cameras that watch people. Not so much for people trespassing, but it's more so to see if workers are safe. You'll have somebody back at the booth can just be watching, and if somebody is in distress, a lot of times the radios won't work because you're so intertwined in all the steel. The radio signal or the cell phone signal doesn't work so well. So that's more of a safety for the workers sort of thing. You also see in this picture, we call this the Spider-Man machine, and I'm sure there's a technical term for it, but basically it's a platform. It's about 10 to 15 feet long, and then it's just a simple car winch like you would have on the front of a Jeep, and we can raise and lower these winches, and then just like Spider-Man, you can kind of crawl along the bottom of the bridge, and you can get a lot deeper, so you can go lower down on the piers. That obviously is not nearly as stable as this steel deck that is bolted and welded to the frame. The Spider-Man machine definitely swings in the wind, and if you lower this winch faster than you're lowering the other winch, then the whole platform will be on an angle. So it does take a lot of coordination between the two guys that are running it. That is, that's what we call the Spider-Man machine as we go around the bridge. Here's kind of the final kind of action picture of us at work. This is called, what's this one called? This is called the Liard Suspension Bridge, the Lower Liard Suspension Bridge. It's in Canada on the Alaska Highway. So when you go up to Fort St. John and you start heading north on the Alaska Highway, you drive for a couple of days and you'll eventually get to this bridge here. You can see here are the guys, they're up here and they're inspecting cables. These main cables are obviously made up of bundles of smaller cables, and they're made up of bundles of smaller wires. And the wires themselves are only about a couple millimeters in diameter, and they will break. So if one of them breaks, it's fine, because there's thousands of cables in a main cable. But you do have to inspect it, and when it breaks, these guys will have little clamps with them, just kind of wrap around, and they'll just do a tiny little repair there. And if you catch it early, and obviously the main cable isn't going to break if you're catching all the little tiny breaks. One thing I'd like to point out in the video, in this photo here, down along the roadway, there's a buffalo. So when you're doing work up north, there are just random animals that are walking across the bridge. And, you know, buffaloes are totally safe if you don't get in your way and you don't antagonize them. So you can see the cars are all staying in their lane. You know, this inspector here, I think actually, I don't think I think the photo is taken of me. I think that's me standing there. And yeah, you just let the buffalo walk by, don't antagonize, and everything will be okay. Those were some action photos of me at work, my colleagues and I. Now we're going to talk about planning a bridge inspection. The number one thing we think about is safety. You know, you're going to have this drilled into you every job you work at. But you know, let's be honest. If I mess up at work, I'm falling potentially to my death. Bridge inspectors absolutely have to think about safety from a heights point of view. We have to think about safety from other points of view as well. Confined spaces. There's lots of either naturally occurring or gases that come from various different generators and things where we'll be in a confined space and suddenly we'll start to feel a bit lightheaded, and then we pass out and then no one knows we're there, and then you can pass away. So a confined space entry plan is something that we always go over. What I just described to you, feeling lightheaded, I've never got to that stage because we always have a plan. And one of the things we do is we have a gas meter that we will lower down with a rope, and we'll wait about 30 seconds and then we bring it back up, and then it tells us the level of oxygen, the level of nitrogen, and then any other toxic gases that are in that area. 90% of the time there's no problem whatsoever, but I would say about 10% of the time there's a dangerous level of oxygen. There's not enough oxygen in that area. So we'll have to open up various different vents. We'll get some fans. We'll blow in some cleaner air because we're always thinking about safety. Here's a picture. This is between Tofino and Ucluelet, and what we're doing there is we're laying out a brand new trail. So right now, if you want to go between Tofino and Ucluelet, there's a highway. We're in the process of designing and constructing a bike path that will go between the two areas. It's going to be between the highway and between the ocean. There's points where the ocean and the highway are very close to each other. So essentially this is just going to be a bike lane. It's just going to be on one side of the highway. But then there's points between the highway and the ocean. There's a couple 100 meters, and the bike path is going to kind of zigzag through the forest. So right here in this picture, you can't see the ocean, you can't see the highway. So here's an area where we're going to potentially be putting a brand new bike path. It's going to be, in most areas, paved. In some areas, it's going to be hard-packed gravel. So the idea is that you'll be able to ride your bikes through it. And you know, why is this in the section about safety? Well, here we are in the middle of nowhere. We're in bear country. There's definitely snakes out here. There's wolves out here. So we're not only thinking about falling, you know, fall arrest and height safety. We're not only thinking about confined space safety. We're also thinking about animal safety. Thinking about being bear aware. What you do when you come in contact with various different animals. That's another real thing we always have to think about. Bridge inspectors tend to go in areas where there's animals and you're coming onto their space. So you really need to, we literally go through courses where we talk about different safety measures for different animals. Some animals are extremely non-threatening. Here is a little shrew. So I'm not thinking about my safety. I'm thinking about its safety, because if I step on that shrew, that shrew's not going to be alive anymore. So I'm not just trudging through the forest like it's nothing. I'm looking where I'm placing my feet, because there's lots of different plants and animals that are down there. So we're also not just thinking about our safety and the safety of our coworkers. We're also thinking about the safety of the animals that we're interacting with. The next picture here. Can anyone, I might as well do this in the chat here. Can anyone spot the animal that is in this picture? It's very clear in the picture, but it's kind of, yep, there we go. Bo got it first. So that is a rattlesnake. And this, I used to think rattlesnakes were just in like Arizona and you know, the southern United States. This is in Ontario. So I was near Toronto, and we were inspecting a bridge, and I was walking along, and again, I was paying attention to the bridge, I wasn't paying attention to my feet, which is dumb. You know, you need to pay attention to where your feet are going. And I heard a rattle, like the stereotypical rattle of a rattlesnake. And I turned around, and lo and behold, there was a full, you know, adult male rattlesnake hissing and rattling at me. And, you know, the kind of the general rule for animals, they don't want to attack you. They just want to be left alone. You know, sudden movements is not a great idea around most animals. So I just slowly started to back up. And then I thought, wait a minute, I do have my camera in my hand. So I quickly snapped a photo as I was slowly backing up. And I got this rather grainy kind of camouflage photo. But yes, that is a picture of a rattlesnake. So we've talked about some safety. So now let's move on and let's talk about logistics. If you're the type of person who likes planning parties and likes planning trips and you're on Expedia a lot, maybe bridge inspection is the career for you, because man, there are a ton of logistics to think about when planning a bridge inspection. Once you're at the bridge, you're inspecting the bridge, it's kind of the easy part. The much harder part is you have to think about the flights and the hotels and the rental cars. You have to think about all the various different agencies that are going to be involved. The owner of the bridge might not be the operator of the bridge, and they're going to have different protocols that need to be followed. There might be a railway that goes underneath the bridge. And I think, yeah, so here's a photo. This was a logistical nightmare. That's why I put this photo in here. So the bridge here is owned by the Port of Vancouver. And if you want to know where this is, if I were to zoom out in this photo, and if I were to look to the left, the Vancouver, Tsawwassen, BC ferries terminal would be to the left. So you know when you get off the ferries and you look over and you see there's all those containers, well, this is where I am. I'm standing in that container port. So the bridge is owned by the Port of Vancouver. So I had to go to a meeting with them, and I had to do all the organizational things and fill out all the paperwork with them. It's operated by West Shore Terminals, so I had to go to their meeting. Underneath, you see some train tracks. The farthest left train track here is operated by West Shore Terminals, but they have a different division that does their rail versus doing their port. These two tracks is operated by BC Rail. They have a different division. And the city of Vancouver also wanted to get involved, even though this is nowhere near Vancouver, it's near Delta. So, you know, the logistics of planning out an inspection sometimes take longer than the inspection. So that's kind of one thing to think about. Logistics. Safety is number one. Logistics is probably number two, and we spend a lot of time thinking about logistics. This piece of equipment that we're using is a really, really fun piece of equipment to use. It's called a snooper truck. And basically, it's just a big dump truck that's needed for weight. And then they affix this arm to it. And instead of the arm going up, which is normally called a bucket truck or a man lift, it's called a snooper truck, and the arm goes down. And this allows us to go completely underneath the bridge. There's very few of these in the world, very hard to rent them. This one's owned by the Ministry of Transportation. Some of them are quite nice. Some of them have heaters in the bucket because you know you're doing inspections all year long. Some of them have places to plug in various different power tools. So this one, they're about $1,700 a day to rent, and they're pretty much booked solid all year long. So that's another problem from a logistical point of view. We're always trying to find a snooper truck to rent because they are a very specialized vehicle. Here's an even more specialized snooper truck. So I took this picture, and there's my boss in the snooper truck. This snooper truck, if you zoomed in here, see these tiny little wheels? Can't see the front ones, but you can see the back ones. Those are wheels that allow you to drive on a train bridge. So that's a very specialized type of snooper truck. It's called a high rail snooper truck. And we were inspecting the bearings right here. To my knowledge, there's only one of these in all of Canada. At least that's the marketing that he tells us. I haven't been able to find anyone else that has them. So he can really just kind of set his price when we're doing inspections. This is a snooper truck that we use up on the Alaska Highway. And one advantage of this one, it's lighter weight, so it can go on smaller bridges. A disadvantage, you see what he's done here, he's got this outrigger, and then he's got a trough that he has to keep dragging along here. So that, you know, you can think about, you know, kind of overturning moment. you did sum of the forces at this wheel versus this wheel, you're gonna get a different moment right here. So he has to keep dragging this trough down because he'll puncture right through the asphalt if he doesn't do that. So this distributes point load from the outrigger. It distributes it as a uniformly distributed load along the asphalt so it doesn't puncture in. And the overturning moment is as a result of us standing here in the bucket. So the snooper truck is most likely to tip over when you're out here, which you don't do. The point is to go underneath the bridge. So you come over, you keep nice and tight to the bridge, and then you suck yourself underneath the bridge. And with this snooper, you can almost make your way all the way to the other side. Here is I don't even really want to call this one a snooper truck because it was quite a permanent installation, but it's the same sort of thing. It is mobile. It does drive along the bridge. Right there is the Parliament building of Canada. So this is Ottawa right here. And then this is Hull, and it connects between the two cities. And we climb down this scaffolding. And this is more so for doing long-term work. I'll go back. There's not a lot of room in these little buckets. So this is for taking photos and zipping around and moving around a bridge quickly. Whereas this sort of platform is for taking measurements. So what we were doing here is we were doing a load rating of this bridge. We wanted to figure out what the maximum load should be on the bridge. And that involves us taking thousands and thousands of measurements and spending a lot of time getting right into the various different members and getting onto different sides. So if we were to be in this sort of snooper truck, we'd be getting in each other's way. So we rented this one instead. This is the same snooper truck as this one. You can see here he's got the small bucket attached. This picture, it's the same truck, but he's got the long bucket attached, or the long platform attached. So this picture, that's me standing there. And what we're doing here is we're doing measurements on the cracking in the bridge piers itself. So the next picture you're going to see is basically we've sucked the snooper truck in. Now we're taking pictures of us on the bridge. So here's the next picture. Same bridge, but now we're underneath. So you can see I've got my harness on. I'm tied off, and the pier itself here, we've got steel piles, and then we've got a concrete pier cap, and then we've got a steel bridge. And what's happening is the concrete is cracking. And I'm sure you'll learn about this in your concrete course. I mean, it's okay for concrete to crack a little bit, but you don't want concrete to keep cracking and keep cracking. So what I do here is I have this little piece of plastic in my hand, and we call it a crack gauge. But all it is it's the size of a credit card, and it's a clear piece of plastic, and it's got a bunch of little lines, and the lines have different thicknesses. And so what I do is I hold the crack gauge up to one of these lines, and I find the line that matches the same thickness as the crack. And you can see right here, it's kind of hard to read, but I wrote 0.2 GW, my initials, Grant Waldie, and I think I wrote there 2015. So in 2015, Grant Waldie recorded that crack was 0.2 millimeters thick. And you think 0.2 millimeters, that's incredibly tiny. I mean, a millimeter is the tiniest measurement you have on your ruler. But on a crack gauge, we have those thicknesses of the line. It gets smaller and smaller and smaller. And 0.2 is kind of at the level where we're not concerned. We're just monitoring it. But you see these other ones, maybe that's 0.3, 0.4. And what we do is we take just a simple Excel chart, and we'll say in 2015 it was 0.2, in 2016 it was 0.3, in 2017 it was 0.4. You can start to see the linear trend. You can see at what point it's going to be larger than what is allowed. And British Columbia Ministry of Transportation, they have various different standards depending on the size of bridge, depending on the usage of bridge. They'll tell you how big that crack can be before you need to do repairs to it. So every year we map out these cracks. Here's a picture. This is called a man lift, and this is an electric one. And these ones work really well on really flat surfaces because you can see they don't have much grip on the tires and they don't have much clearance. They only have about 6 inches of clearance. So these work great on a nice flat surface. If we were to drive it down the bridge, and again, this gets back to that logistics problem of planning an inspection, this wouldn't work. You can't drive this thing on gravel. You can't drive it off the road. A bunch of alarms will go off and then it just shuts down. And now you've got a man lift that's just stuck in the middle of a slightly steep parking lot. So you do have to think when you're planning the inspections, what kind of surface are we going to be driving on? How tall do we need the man lift to be? Man lifts can go up to, I've seen 10-story tall ones. Here we only need 2-story tall. So thinking about those logistics of how you get up to these top braces, measure things. It's always an important thing to be thinking about. So what do we do when we want to get way higher? This is that same bridge I showed you of the Buffalo. When you're climbing the cables, it's easy to see the cables. But what do you do when you get up to this place up here? So we've rented a mobile crane truck, and you've probably seen these involved in various different construction elements. And we've got a basket here, and there I am, just standing in the bucket. And of course, this is in the wind. It's going to be moving back and forth. And we can get up and we can look at the saddle. This is called the saddle of the suspension bridge. We can go along. We can take some more photos here. And this is another place to get a photo to see if the towers are tipping. You wouldn't think that a giant suspension bridge would tip. There's 2 reasons why a suspension bridge would tip that quickly come to mind. One is you might have a lot of erosion happening in the river, and it might be actually slowly tipping these towers over. We've had bridges where we've been up in the crane, and we think, wait a minute, I'm perfectly level. I'm looking at this tower, and that tower doesn't look level anymore. So we'll start just by visually seeing it, and then we'll get surveyors on site who will do actual perfect measurements. We found sometimes that these towers are starting to tip over. And it was a bridge. It was up north. It was in northern Manitoba where an entire tower was starting to tip over. So then we got divers to do ultrasound testing underneath the water, and we found that there were these big erosion holes underneath one of the piers. And we caught it early, luckily. Basically, what we needed to do is we needed to put down sheet piles. We created basically a fence around the pier, and then we filled the pier with a bunch of rocks and a bunch of concrete. There's no real way to get the tower back to being plumb unless you wanted to do erosion on the other side. But the tower now has a permanent about 2-degree lean to it. We did whole calculations to see if what sort of eccentricity and accidental moments that this would put into the bridge, and we determined that it was still okay to be allowed to be open in its state. But we're certainly glad that we caught it. So that's some of that add-on work where bridge inspectors, we see a problem, we immediately notify the people that are in charge of the bridge, and they come back to us and they say, okay, well, now what? We need to fix this, right? So that, luckily they had the funds, the emergency funds available, and we got that fixed really within just a couple weeks of notifying the authorities of the problem. So as far as carrying out the inspection, we've talked about safety, we've talked about logistics. A part of logistics is all the various different issues you have with access. Everyone can drive to a bridge if it's a bridge that you drive on. What happens if it's a bridge that trains go to? Am I going to rent a train to get to the bridge? That's way too expensive. So you'll need, we use what's called a high rail pickup truck, and it's literally just it's a Ford F-350. It has those special train wheels that are attached to the front of it. You can drive along the highway just normal, and then when it gets to a crossing, it kind of parallel parks itself on the rails, and then you press a button, and the train wheels come down, and it locks itself into the train tracks, and then you start driving along the train tracks. Well, what happens if you want to look underneath the bridge? So here I am. We rented a fishing boat for the day, and a lot of times the accounting department of Parsons, we're a giant company where we have these purchase orders for millions of dollars, and the accountant will see an invoice for $200 from, Sam's Fishing, and I'll get a phone call. What's going on here? Why did you charter a fishing boat? I said, well, that was the easiest way to get to the bridge. So this is literally a fishing boat. This is on the Fraser River. There's the Alex Fraser Bridge in the background, and this was the easiest way to get to these piles. And so what I'm doing here is I'm doing what's called drill testing. So I've got a cordless DeWalt drill, and again, you have to think about logistics. I don't have any place to plug it in, so you have to charge all your batteries the night before. And I am pushing into this timber pile, and I push, and eventually the bit will give way because the inside of the pile will be rotten. It kind of rots from the inside out. The inside of the pile will be hollow, and I'll push in until it gives way. So now I know there's a hollow spot. I'll pull out my drill, and then it's literally a bent coat hanger. We call it a shell thickness indicator. Literally, it's a bent coat hanger, and I stick it in, and I kind of pinch it off with my fingers. A little bit hard to describe without kind of showing you with my hands how I do it. I then basically measure the remaining shell thickness of that timber pile, and you pull it out, and I pair it with a tape measure or a ruler, and as long as there's 2.5 inches remaining, again, it depends on the weight of the bridge and what's on the bridge, but as a general rule, as long as there's 2.5 inches of shell remaining, then that pile is deemed to be okay to carry load. And when there's less, I'll keep kind of cheese gratering this pile until I find out how much of it needs to be replaced. And I've done this presentation a few times before. People always put up their hand and they say, wait a minute, the rot comes from water, and you're drilling the pile full of holes. Doesn't that make it even worse? Because haven't you introduced a bunch of water if you start drilling holes? Great question. We have these little plugs. They're treated with basically preservative, and we plug all of the holes. So I will, I don't drill it 100 times. I maybe drill it 1, 2, 3, 4 times, and then we'll plug the holes, and we'll monitor it on a piece of paper. We'll say either, row 37, pile 2, come back to do inspections next year, or we'll say, replace the pile, depending on how much rot that we find in the pile. So here I am at a bridge. This is in Chilliwack. And we couldn't figure out how to get to the bridge because the boat idea didn't work. We didn't have any place to launch the boat anywhere near. So I literally got in a fly fishing tube. I went down to Canadian Tire and I bought a fly fishing tube, and I'm wearing a life jacket, and I think I was wearing a wetsuit underneath this. No, actually, I was wearing chest waders. I was wearing fly fishing chest waders, and I put on some flippers. And I just kind of push myself out to the bridge. And what I'm doing here is I've got a hammer in my hand, and I'm just tapping around the bridge, and I'm doing called a delamination survey. So when you pour concrete, as I think you've learned in Camosun already, you've got concrete, you've got the rebar, and it's all mixed together to create reinforced concrete. Sometimes little cracks will happen in the concrete, and then water will go through that crack, and then water will get onto the rebar, and then the rebar will start to corrode and rust, and it will do it'll kind of pop off the concrete, not enough that it actually falls off the bridge, but it just creates a tiny little airspace. And when you hit it with a hammer, it makes a completely different sound in concrete that hasn't had this happen. Now it's okay because that layer of concrete is generally just there to protect rebar. But if the rebar is starting to pop the concrete off of it, that means the rebar is starting to be compromised. That means the rebar is starting to corrode, and you're starting to lose section in the rebar, and you're starting to lose strength in the bridge. So the delamination itself is not the problem. It's a sign that there is a problem potentially with the rebar. So I will spend hours with a hammer just going tink, 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 all across a bridge, and it doesn't take more than about 5 minutes to become good at this. You learn the sound that good concrete makes, and you learn the sound that delaminated concrete makes, and it makes a completely different sound. I'm not good at visual effects, so I can't describe it with my mouth. It makes a totally different sound. And then with spray paint, I will be marking out the areas that are delaminated, And if a certain percentage of the bridge is delaminated, then it makes economical sense for us to get a contractor to come to site, and they take a jackhammer and they chip out the delaminated concrete, and then they put in little anchors and they put back in fresh concrete, or they might even cut out the old rebar and put in new rebar. So we'll see some photos about that a little bit later here in the presentation. This is in Surrey. Sorry, I don't have more Victoria photos. I spent the first 9 years of my life mostly working in Vancouver, so a lot of these are in the greater Vancouver area. This is called the Surrey Sea Dams. A lot of people don't know this, but there's a couple rivers in Surrey, the Serpentine River and the Nikomeco River. They flow downstream like a regular river should, but when the tide is high, they actually flow upstream. So the water from the Strait of Georgia will actually push itself up the river, and the rivers are used to irrigate crops. You can irrigate crops with fresh water. If you start irrigating crops with salt water, you're going to kill all your crops. So what the people have done in Surrey is they've created these dams, and you don't even notice them because they're not on the main roads, and when you drive across it, you just think you're driving across a bridge. But what it is, it's just a series of tunnels, and the tunnels are only as wide as the bridge. So they're only about 20 feet long, and there's gates. And so when the water is flowing downstream, when the fresh water is flowing to the ocean, the gates are open. And when the water starts to flow upstream, when the salt water starts to flow up the river, there's no machine involved or electricity, just the natural flow of the river closes these gates. And so it's a really ingenious idea. I don't know anywhere else in the lower mainland that uses this. How do we get in there to inspect it? There's no way we could boat in here. There's no boat launch. And my float tube idea just didn't seem as safe. I wanted something a little bit larger. So this is an inflatable kayak. And there's my coworker standing on the shore taking a picture of me. And basically what I do is I would paddle into one, and then I would come out and I would paddle into the next. And that's how we did the access. That's how we got over the access challenges for this bridge. This is a bridge. This is a train bridge, and it's probably about a 3-hour train trip from the nearest city. So you get in the pickup truck, you get on the train tracks, and then you clickety-clack along the train tracks for about 3 hours. How do you get underneath to do the drill testing? There's quite a bit of a current. You can see with my hand there, I'm kind of holding onto the bridge. Well, you can maybe make it out in the bottom of the picture. There's a guy's shoe. That's my coworker. It was his job to be paddling the canoe around the bridge, because I can't really it's really hard to paddle a bridge and drill test a pile and hold onto the bridge all at the same time. So his job was literally just to paddle this canoe. We needed something more sturdy than this guy, because this guy could get easily punctured. Here you can see there's lots of twigs. A lot of times with the canoe, we would go right up on top of a beaver dam, so we couldn't do the float tube. We couldn't do the inflatable canoe. So here we had an actual aluminum canoe. We could easily launch from the back of the pickup truck, and I would do drill testing on these piles. This picture here, this is the SkyTrain in Vancouver. A lot of people picture the SkyTrain as being above ground, which most of the network is above ground. But when you leave, I think it's the stadium station, you then go underneath Vancouver and you're driving around in the SkyTrain underneath, and basically now it becomes a subway. So I'm taking this picture, and you can see my coworkers are standing there. There's no railing, so you kind of just stand sideways as the subway just flies right past you. And so this is doing an inspection of the tunnels. You can see this white stuff here. We call it efflorescence. It's basically leaching of the water through the concrete, and it does a reaction with the concrete, and it starts to kind of break down. If you see it just in one little patch, not a problem. You mark it as monitor on your sheet. But if you see it everywhere, and maybe you need to get a contractor in, and maybe the contractor needs to break out some of the concrete and patch some of it. So this is on the Alaska Highway again. And what I'm doing here, standing inside a culvert. Now I know, if you're, I don't know if Zoe has taught you too much about culvert and pipe flow. A lot of times we picture pipes as being about 6 inches in diameter, or maybe 12 inches or 2 inches. Sometimes the pipes get huge. You can see this culvert here. I'm 6 feet tall, so that's potentially maybe a 4 meter tall culvert. So this is for the runoff of all the various different rain areas, the catchment areas. Instead of building a bridge on the Alaska Highway, which would be quite expensive, they just put in these underground culverts. And what we're doing here is we're measuring, I guess, it's a non-technical word, but kind of the crunching of the culverts. They're supposed to be circles, but they're turning into ovals. And basically that happens because the culverts are starting to fall apart. They're old, they're 50 years old. And what I do there is I'm taking in my hand here, I've got a laser distance measurer, and it shoots up to the top, and then it bounces the laser off, and it tells me that that distance there is 2.364 meters, something like that. But then how do I measure the distance from my hand back down here? I can't take the laser distance measurer and stick it into the water. It's not going to work. So what I have is I have a 1.5 meter long stick. I put that stick into the water. I put the laser distancer on the end of the stick. And then what my coworker here is doing is he's just adding the two numbers together. In fact, he's just writing down my number, put it in Excel, and then the 1.5 meters is being added later. So, one thing I want to impress upon you in this presentation, we do a lot of fancy math and a lot of shear embedding moment diagrams, a lot of differential equations. We do a lot of really complicated stuff when we go through Camosun and UBC. When it comes to the real world application, a lot of times it's a stick and just simple adding and subtracting. So you got to kind of think outside the box and do just kind of simple, how would we figure this out in the real world? Same sort of measurement I do after this picture. I don't have a picture of it, but I want to measure the width of this culvert as well. So instead of trying to lean over and put my laser distancer here, and then it's a circle, and then slipping out and getting all wet and going down. It does happen, by the way. We absolutely, I don't think you're a culvert inspector if you haven't at least fallen once in a culvert. What I do there, again, is I put my stick on the midway point, I hold it out here, and then I shoot this way, and then we add those two numbers together. So again, this is just like the crack monitoring that we were doing before. We do measurements, every 5 feet along these culverts, and then we put it into Excel. And we can see, when was this photo taken? This photo was taken in 2015. We can be tracking that in 2015, it was 4 meters tall. In 2016, it was 3.95. In 2017, it was 3.9. We can start to see how the culvert is ovaling, is the term we use. It's turning from a circle into an oval. And then we can use this to predict when it's going to get to the point that it's going to collapse. And we can give that heads up and that warning to the authorities to say, you need to line this culvert, you need to fix it many years before that happens. This next picture, this is also a culvert inspection. I put this in here because this was just fun. This is a big highway culvert that's about 4 meters in diameter. This is in West Vancouver, and this is just a regular drainage culvert that's going from one residential road underneath someone's property to another residential road, trying to make its way from West Vancouver down into Burrard Inlet. So if you can picture Vancouver, if you know much about the topography of West Vancouver, it's very steep. All of West Vancouver, it's like the Hollywood Hills. Everything is on a hill, so there's a lot of water flow that needs to make its way off of Cypress, off of Grouse Mountain, off of Seymour Mountain, and there's a network of just a ton of these culverts. And you can see how lush and green it is. I think I was doing this in November, so it was certainly quite rainy. I walked in to this side of the culvert, and it's quite dark here, and I knew from the inventory that we had that this was a 100-foot long culvert, but I saw there was light only about 20 or 30 feet away. And I thought, well, that's odd. What is this light? Because I know it's 100 feet long. So I went inside the culvert and I started walking along, and that is part of our job, to look at the walls of the culvert to see if anything is falling apart. And I got about 20 or 30 feet in, and there was an opening, and I stuck my head up in it, and I was inside someone's property. So the culvert goes from one street underneath someone's house through their backyard to another street. At the halfway point, there was an access hatch. So I just kind of popped my head up, and I was looking around because we're looking for signs of settlement. We certainly take into account things that we learned in Bau's soil class. We're looking to see slope failure and various different things. And I'm just taking some notes. A fellow walks over to me and says, "Excuse me, who are you? How did you get here?" And the guy I was talking to was the security guard, the full-time security guard that works at this mansion in West Vancouver. And he said, we have full-time security. How did you get here? And I explained to him, I just walked through the culvert. And since then they've put a gate on there because this is obviously a big security hole. And I casually asked him, I said, this is a pretty big house, who lives here? And he said, well, this is the owner of the Vancouver Canucks. He owns this enormous complex in West Vancouver, and we've got 3 or 4 full-time security guards here, and we can't believe someone penetrated our security. So, for anyone who wants to know how to break into houses, culverts, that's kind of the way that it's kind of an often overlooked security feature of houses. A second house in West Vancouver, as I was walking through the culvert, it was the same sort of thing. They had done a glass enclosure of the culvert, and I stuck my head up, and I was literally in someone's living room. There was like a grand piano, and there was an expensive painting. I was literally in this bubble in someone's living room, and they had done this because these culverts in West Vancouver, a lot of them are fish-bearing streams. And a lot of them have fish gravel on the bottom of the culvert, and they have salmon, full-size, like 30-pound salmon swimming through them. And this multimillionaire or billionaire, whatever, thought it would be cool to put a glass enclosure over the top of the culvert so that while he's having his dinner parties, he can look down and see the salmon. He wasn't home at the time, but he would have seen me walking through this culvert. So here's a picture. This is the new guy. We always get the new guy to go up a ladder. You don't think it's too scary going up a ladder, but it's a little scary for some people. So I'm holding the ladder because we want safety first. And he goes up the ladder here, and what he's doing is he's undoing all these bolts in this. It's a steel trapezoidal box girder bridge. And again, you got to think about logistics and planning. He's got the ladder. I let him set this up. He's got the ladder on the door. He's undoing all these bolts. How are you going to open that door when your ladder is on the door? Right? It won't work. So he hadn't thought ahead here. So he had to come back down to move the ladder and the door open. So a lot of times you got to kind of think ahead about how you're actually going to get into that place. I see a quick question in the chat here. Do you need your PNs to get a job as a bridge inspector, or can you do it as a technologist? You absolutely could be a bridge inspector as a technologist. The problem might be just advancement and signing off of the bridge itself. So if you're going to work on a team that has 3 or 4 inspectors all on site all at the same time, you can easily be a technologist, you can easily be an EIT, absolutely, but there is going to need to be a PN on site who's going to be signing off on that bridge. So if you want to be the lead bridge inspector, at least in Canada, you would have to be a PN. It would depend on what you're inspecting. If you're doing culvert inspections and we're looking for is there a blockage at either end? Are there erosion issues? And is the culvert collapsing? And we're talking about culverts that are 12 inches to maybe 3 feet in diameter, and there's thousands of them that you're looking at. I can see a technologist doing all of the inspections and then going over the findings with a professional engineer. There would always have to be a professional engineer involved if you're going to be giving engineering advice and engineering recommendation, not necessarily on site all the time. Yeah, so I see somebody just said in the chat that they did that. Exactly. So you absolutely could be a bridge inspector as a technologist. You just wouldn't be the one signing off on the report. And if you have a small enough company that says, look, we don't have a team of 20 people, we only have 2 people that do bridge inspections, it's certainly more advantageous to have your PEng. I'm a big proponent of encouraging people to get your PEng, but it doesn't totally limit you if you stay as a technologist to be a bridge inspector. You certainly can do some levels of it as a technologist, for sure. So that's a good question. Here's a picture of me. This is me inspecting a bridge. Here's the bridge here, and it goes into a chemical plant. You can see there's a train there. So the train drives in like raw ore, like raw iron ore, and it gets into the plant, and then it basically drops the iron ore into various different hoppers, and they're heating it up in hundreds or even thousands of degrees furnaces. They're doing various different things to extract the minerals that are in the ore. So this specific plant, I know it did gold. I didn't go into the gold area. You need a special security clearance because you can imagine even a tiny little ounce of gold that you steal from work would be extremely expensive. So I wasn't involved in the gold ore plant, but I was specifically in the plant that was doing cadmium. Cadmium is the main ingredient in batteries. So the reason why I was wearing all this is because I was literally walking around in full clouds of pulverized battery acid, which if you take a couple breaths of that, you'll be dead. So I had to wear a respirator at all times, and people that work there full time get their blood tested once a month. And by BC standards, there's an acceptable level of cadmium that you can have in your bloodstream, which is awful. You would think it would be 0. There is an acceptable level, and when they get above that acceptable level, then they can't work in the plant. They have to take a month off for their acceptable level to go back down. So yeah, this is again thinking about safety, thinking about logistics, thinking about access issues. This job really kind of had it all. This is doing some helicopter inspections of bridges. Some bridges, they're just too dang hard to get to. So you hop in a helicopter and you fly. We obviously do a economical trade-off kind of calculation. We look at how much money would it cost to hike there versus how much money it costs to helicopter there. Hiking might take 3 days. So at your hourly rate, that's a lot of money. And here's another kind of tip, general rule of thumb. An engineer costs $1,000 a day. It doesn't mean he gets paid $1,000 a day, but an engineer costs a client about $1,000 a day, and that takes into account markups, and that takes into account renting out office space and renting vehicles and various different things. So when a client asks me, how much do you think this inspection is going to cost? If I think to myself, well, it's a day to fly there, it's a day to fly back, and from experience, that type of bridge will take me about 2 days. So now I'm up to 4, and rule of thumb, for every 1 day in the office, you spend 2 days writing the report. So that would be 8. Round up a bit, $10,000. So that's kind of a quick way when someone asks you, when a client says, how much is this going to cost? $1,000 a day. This is kind of the way you look at it. Now helicopters are $1,000 an hour. So you do have to do that calculation a little bit differently. We helicoptered to a couple of bridges. Here's a picture. This is not a flattering picture of me, but I will show it anyways. This is long. This is an 8-year-old photo. I had just hiked the West Coast Trail. So we had inspected all the bridges. West Coast Trail is it's 75 kilometers long, and it's on the west coast of Vancouver Island. I think most people on this call probably know about it. And we had spent 7 days hiking and camping and inspecting all of the different trail bridges that are along that trail. That's definitely a job where we would get a technologist, 100%. In fact, the main engineer on that job, this is 2012, so I wasn't yet a PEng. So the main engineer on the job was a PEng. He was, do those shorts keep the bears away? Peter asks. Yeah, my wife recently got me to throw away those shorts. She really does not like them. So I wear more stylish shorts now. You can see I have bear spray onto me there. So to go back to that technologist question, the main engineer was a PEng. He was in his 50s, but he was not in the shape for hiking the West Coast Trail. And I was in good shape. I was an EIT, but I still wasn't in really good shape to hike the West Coast Trail. Since then, I've done a lot more training. We literally hired my best friend, and I did full disclosure. I said, this is just a friend of mine. He's not a technologist at all. We just need someone to help us hike this thing. We need someone to be kind of the pack mule. So, absolutely, there's a level of bridge inspection that just comes down to physicality. Doesn't matter, what kind of physical, what kind of training you have. We want someone who's in good shape to be able to do certain types of inspections. Here's just another picture of that. This is our Monday morning staff meeting. So literally, we're bringing the tents, and we're eating meal ready to eats and mountain house type meals. This is how we do our meeting before the inspection. So carrying out the inspection, we've talked about access issues. Let's talk about some forms and standards. How are we doing time here, Peter? I think you said till 2 o'clock my time. 1 o'clock, is that's when I should probably finish Victoria time? A little bit before 1 o'clock? I'll just let you answer that in the chat here. So forms and standards, British Columbia, before 1. Okay, perfect. So I'll wrap it up pretty soon then. So forms and standards, British Columbia Ministry of Transportation, Public Works, Parks Canada, they're all going to have different forms for sure. Here I go, page 1 of 1. I don't like this form. This is too hard to read. It's too tiny. I don't even know if you guys can read this. This is one of the standard forms that we use, and it's a 1 to 10 scale, or there's a 1 to 5 scale, or then they get cute and they go a 5 to 1 scale. So every time as a bridge inspector, I ask the client, I say, what kind of form are you using? Because obviously, if they're using a 1 to 5 and I'm using a 5 to 1, there's a huge difference there. So this comes back to the logistics and the planning. There's lots of meetings to decide how are we actually going to be rating these bridges. Here's another bridge report, where we talk about the deck and the superstructure and the substructure and what material is it made out of. Here I see a lot of 7s, so maybe this was a 1 to 7. If the structural condition is good and that's a 7, I would assume maybe this is actually a 1 to 9, because very good would probably be a 9. And then we talk about maintenance recommendations. We look at the bottom here. Here's page 1 of 7. So this is Public Works, Alaska Highway. They like to have a picture of the bridge, they like to have an elevation and a section of the bridge, a little description. And again, these are all templates. Our clients are incredibly impressed when we turn this out really quickly, but it's a template, like you just drag and drop a lot of these things in here. So that's another tip. Make sure you really heavily rely on templates. This is a layout, because when someone says, what is L1, you want to have a good description of what L1 is, because someone might put L1 here, I put L0 here. So another really good tip, really lay out, where's north? Is that girder 1, 2, 3, 4, 5, or is that girder 1, 2, 3, 4, 5? Make sure you're laying things out properly. I can't tell you the number of bridge inspectors that I've seen not lay out things properly. Or here I talk about significant inspection concerns, and this is a lot of stuff that comes with experience, because you'll go as a junior engineer and you'll say, is that bad? That looks bad. And the senior engineer might say to you, no, we see that all the time. So that kind of comes from experience. We have a difference between material condition rating and performance condition rating. So to give you a good example, a drainage pipe that's brand new but is clogged would have a high material condition rating that would have a low performance condition rating. That makes sense, right? It's clogged, it's not performing, but it's brand new, so it's good material. But then the flip of that is a drainage pipe that's all rusty and falling apart, but is freely draining. That's going to have high performance but low material. A lot of times material, MCR and PCR line up, so a lot of times they equal each other here. Just a lot of forms. A lot of times you get the EITs or the interns or the co-op students or the technology. A lot of times you get other people to fill out these forms for you. Here's just another form that we have. More forms, lots of different forms. So I always send it to the client and I say, what kind of form do you want to use here? Frequency of inspections, some people once a year. Once a year is pretty common. Sometimes we do every 5 years if the structure is in really good condition. Gear list, I would suggest what you do is you come back to this recording and you screenshot this, and then you take this to your employer and you say, hey, this is what they do. We have all these pieces of gear. So I'm not going to go through every piece of this gear, but you can, I mean, a discerning person who's been to Home Depot a number of times will be able to figure out what all these pieces of gear are. There's one good picture. There's another good picture. So that's something to maybe screenshot and look at a little bit slower. There's some more pictures, various different tools that we use for drill testing. There's that rusty coat hanger. There's the shell thickness indicator. In a writing report, you always want to make sure you've got the data nicely organized and backed up, organizing all the photos. I showed you a bunch of simple reports. You can start putting it into Microsoft Access. You can start doing database type things, and then structural health monitoring. That's where you actually put gauges on the bridges, and you can be monitoring things in real time. We talked a little bit about add-on work to inspections. When you find there's a problem, you want to, how do we fix this problem? How do we rehab the bridge? Do we do a complete new bridge? What's kind of the pluses and minuses, the pros and cons? We do things called a life cycle cost analysis, where we look at how much money would this bridge cost if we fixed it now versus we placed it later, and that gets into economics and business planning. So bridge inspection really kind of combines a lot of these things, a lot of different disciplines to figure out those reports. We started using drones to inspect bridges. That gets you to places that you couldn't normally get to. Here's a three-dimensional computer map that we made of a highway. This is 5 kilometers long, and then we surveyed this with a drone, created this whole topo map. We work on a lot of rehabilitation works. Here's a pile that was rotting, and then we replaced this section. Kind of how you open things up and you bolt new things on. Here's what a rotting pile cap looks like. Sometimes they just split right apart. And there's the new one being put in. Here's basically impact damage. A vehicle drove into this, and then the guy drove off. You can see all that. This is grain. The guy was carrying a load of grain, and we literally drove down the highway like breadcrumbs, and we followed him all the way to his barn because it was a hit and run. So there's kind of what it looked like before, and there's what it looked like after. Here we're doing just some deck rehab. We're fixing some of the joints in the bridge. Kind of before and after pictures here. There's what a new joint looks like. This seismic retrofit, we just put on these braces because in an earthquake we determined that that would just fall off. So we put on these braces. This wall was tilting over, and what we did here is we used this machine here to drill in some anchors and put in some rebar and then cast a brand new wall. And then I think this is my final one here. This is the Alaska Highway, and you zoomed in right here on the bridge. This is starting to crack, and you can't quite see the crack. So what we do is we spray on stuff called dye penetrant, and it uses a dye to penetrate into the crack, and then you can more clearly see that there's a crack, and then you can start to measure it, and we've actually now done a full rehab of that bridge. So that finishes my PowerPoint presentation. I believe, Peter, you said I should end a bit before 1 o'clock. I don't know if 15 minutes before is 1 o'clock. I could certainly end right now if you want. I also have other pictures if you want me to keep going. People can ask questions in the chat if you want. I'll leave it up to people to tell me in the chat what they want me to do. Peter says, what? Oops. I'm assuming you started to type a question and then you hit return. So I'll wait for you to finish typing that whole question. Oh, what is everyone's preference? I used to be a student, Peter. I know everyone's preference. It's let's move on. That's a good question. Email in case you have a question. Yes, Sam. Yes, absolutely. So what I'll do here, I will just, instead of saying it to you out loud, I will just open up. I'm still sharing my screen, right? So I'll just move over a Microsoft Word document here, and I'll make it a little bit bigger. So I get to see how fast I can type. So my name is Grant Waldie. My personal email is this. So if you want to ask questions about maybe UBC versus Camosun or job stuff, maybe ask that. If you want to ask more professional questions like, can I have a job? Which I'm not really in charge of that anymore because I don't live in Vancouver, but I can certainly help you out with that. My LinkedIn, I think my LinkedIn is just this for LinkedIn. My own personal resume, you'll find here. And I think that's probably the best for getting in contact with me. Are there any other countries that you considered relocating to before settling on the States? Do you know if tech credentials might easily transfer to other countries? Great question. So as far as living, I like living in Canada and I like living in the United States. My wife and I have considered living in France. Maybe I've asked my boss about this because Parsons is a big international company, and they are very open to you moving around. So France is at the top of our list. We think maybe in 5 years we might move there. Argentina is also one that we've considered about. I love traveling. I don't necessarily love living in every country of the world. I would love to travel to way more countries than I'd love to live in. So I think France and Argentina are kind of the two ones that I've talked to my boss about, and I've talked to my wife about, and I've talked to my family about. You have a question here. Do you know if our tech credentials might easily transfer to other countries? I know when I was transferring from Canada to the United States, I had to get what's called and I'll write it down here, a TN visa. And I think that stands for temporary national visa. Very easy to get a TN visa when you're a Canadian citizen wanting to work for an American company and you have a professional engineering degree. Very easy. I don't know if Camosun College diploma would also work for that. We used to be under NAFTA. Now we're under the United States and Mexico-Canada Act. I don't know if that's changed, so I'm kind of dodging the question by saying check with a lawyer. I know PNG, it was really simple to get a work visa to work in the United States. Very simple. It's going to be more difficult if you aren't a PNG, but I don't want to discourage you and say it's not possible. I'm just saying I know it's a lot easier with a PNG. As far as like credentials with working down here, if you're a bridge inspector in Canada and you want to be a bridge inspector in America, your boss is probably going to be very okay with a lot of the same credentials. But again, it's that PNG that is very helpful to transferring down. I had to get a PE down here, which is a whole different set of tests. I had to write a whole bunch of different tests down here. And I'm still studying. Like just this morning, I was studying for another test because you have to write 2 different tests if you want to do it in California. And they're completely different tests. So you never stop filling out paperwork and you never stop taking tests is kind of the way of looking at it. But it's a lot more enjoyable when you're getting paid and you don't have 6 courses or 8 courses at the same time. So maybe that's my encouragement for people that are in school. You go, man, when does the test taking end? It never ends. But I'm only studying for 1 test right now, and I do like 1 a year sort of thing. So it definitely gets better.
Awesome. Thank you for your input, Grant.
You're welcome.
Okay, well, Grant, I guess that kind of brings us pretty much to the end. Certainly, if you've got a little bit of time, if anybody wants to ask any other specific questions, hopefully accommodate them. I think a couple of these guys in the group are working. There's a project involved with this course, and they're looking at things that relate to bridge inspections and stuff like that. So probably the reason behind. Get your email.
Yeah, and I really want to encourage you for 2 reasons. Reason and I have a selfless reason. So from a selfless point of view, I would love to help people out. I mean, when I was young, I liked it when senior engineers helped me out. So from a selfless point of view, please email me and ask me engineering questions. I would love to help you out. But I'll be honest, I have a selfish reason as well. every time I do these types of presentations and help people out, I get to put it on my resume. So I am totally happy with people asking me to give presentations or to speak or even ask little questions, because then I can say, was a mentor to Camosun College students. So do not feel awkward in asking me for questions. I absolutely, from a selfish point of view, love it. And from a selfless point of view, I want to help you as well. So feel free to use those emails.
Okay, then. Well, I guess if we can all thank Grant, I don't know if you turn on your mics, if you got a mic, and clap or say yay or thank you, or wave your hands up and down, whatever you want. There we go. We got a we. And thank you very, very much, Grant, for taking the time to do this. And what more can I say?
Perfect. Well, thank you very much. And you could send me a link to download the recording. That would be great. And
I will do that for sure. We'll just get the rest of the thank you here, and then I will stop recording.
You'll kick me out. Yeah, you'll kick me out.
No. I think the system kicks you out at about 1.
Gotcha.
Thank you very much, Grant.
Thank you, everyone. And good luck on your studying. And I'll talk to everyone later.
Okay, and I'm just going to end the recording here now.
Well, thank you, Peter.